Hello, everyone, and welcome to our webinar, Large Diameter Crossover TBM, Success in Turkey and Future Applications. I'm Desiree Willis, Robbins Marketing Manager, and I'll be your host throughout the webinar today and during the Q&A at the end. With that, I'd like to introduce our three speakers today. Brad Grothin, PE, Robbins Technical Director, Professor Dr. Nuh Bilken, Chairman of the Executive Board of the Turkish Tunneling Society, and Şevket Kilic, Esme Salihli, Project TBM Engineer for Contractor Cullen Construction. And our first question for today, I'd like to ask to Brad. Can you tell us a little bit about what we're discussing today and a bit of the background on the TBM for the Esme Railway Tunnel? And you know, it's our featured project. So just tell us a little bit about the TBM.
What we want to talk about today is it's always nice to have a successful project, and especially a large diameter one in Turkey where they're known for their complex geology. This particular one used a crossover machine, as you alluded to. In this case, it's an XRE, so a crossover. It crosses over between rock and EPB technology. So it's able to operate in full open mode for rock conditions or full closed modes in EPB conditions. In this, and so that's a machine in general. We can maybe, as we learn more about the project, we can talk a little bit about how aspects of that were used. The history of the machine was actually originally designed for a different project. It had a lot more transitions, and so the machine is especially set up for that. As we look at this project and what makes a successful project, there's several aspects, and so really it's nice to be able to go over all those how different aspects of the machine and the project really need to work together to make an overall successful project, especially one this large diameter where you have a special set of risks and challenges associated with it.
Brad, can you tell us a little bit more about the Esme Railway project?
Sure. The Esme Railway project is part of a high-speed rail network, ultimately being done for the client being Turkish State Railways. And ultimately, it's going to connect some of the major population centers in Turkey, taking travel times down from about 6.5 hours to 3.5. So overall, it can have a great impact on the country as a whole, really increasing the efficiency of travel within the country. It's a large diameter, so it's a double track setup for a single tunnel, so really increasing the efficiency of excavation and travel for the project. This is only a short section of the project. So this is about a 3-kilometer section over I think it's about a 60-kilometer overall tunnel of tunneling is planned.
Great. And Şevket, can you tell us about the project in Turkey, just a little bit more about it, the geology, and what made you decide that this particular machine would work well?
To make a well-rounded soil analysis will carry you one step ahead before you start to excavate tunnel. For this reason, 15 drilling applications have done in order to determine the geologic parameters of the tunnel. In this site investigations, each borehole have 200 meters interval within them. So when we start to excavation, we were ready for whatever soil type we could encounter. We started to excavation with altered gneiss at the beginning, then passing through a soil complication named melange, which contains gneiss, sandstone, claystone, sandstone, quartz, and silt. We completed the excavation with mudstone. It was determined from the geological reports that the underground water level remaining above the tunnel axis along the road, but small amounts of groundwater were encountered along the tunnel line. If we talk about use TBM on the project, TBM is a convertible type crossover model between rock and EPB. It is specially designed for variable and inconsistent soils. It can be used as both EPB and single shield hard rock. We use in EPB mode in this project. It is a very flexible construction practice for groundwater inflows. It is designed to cope with both weathered ground and rock environment conditions. Cutter diameter is 13.77 meters. Total length of the TBM, including cutter and backup, is 105 meters. Cutter drive includes 19 electrical motors. Each motor has a power of 220 kilowatts. The total cutter power is 4,180 kilowatts. Total installed capacity of TBM is 10 megavolt ampere. Maximum cutter speed is 4.6 RPM in hard rock mode, 2 RPM in EPB mode. Maximum torque is 52,000 kilonewton meter, and breakout torque is 78,000 kilonewton meter. The maximum thrust force is 260,000 kilonewton, and exceptional thrust force is 282,000 kilonewton. I should especially point out that TBM is really powerful. There is a screw conveyor on the TBM, which is also used in standard EPB TBM. There is also a hard rock belt system to be used as an alternative to the screw conveyor when conversion to single shield hard rock mode on the TBM. On the cutter, there are 63 single disc, 8 double disc, 277 scrappers, and 32 sets of buckets. Cutter provides rotation both clockwise and counterclockwise. There are 8 foam and 10 water line on the cutter, which ensure the conditioning of the ground and prevent the cutter head from being worn. It also has 7 wear sensors. As a result, the TBM specifications show us that the TBM is an extremely powerful beast. In addition, I would like to state that it is extremely important to conduct field studies in order to collect geologic data before excavation works. Thank you.
Thank you. Dr. Bilken, do you think Turkey's geology is particularly well suited to crossover TBM use? Do you think other areas of the world have a similarly variable geology that could use crossover?
Well, I will answer this question first explaining how the geology is complex in Turkey. The problem is Arabian plate is moving towards Turkey from the east, and the African plate is moving up to Turkey. So they created 2 major fault zones. One is Northern Anatolian Fault, and the other one is South Anatolian Fault. And they create tremendous problems. And we had all problematic tunnels around these zones. For example, we had excessive squeezing of the ground, excessive water ingress, TBM face collapses, and as we experienced in Karga project and Doğançay project, Gerede water project, and Nurdağ railway project, we had a lot of problems. Mixed ground with ophiolites, graphitic schists, and melanges with boulders are other fundamental difficulties. A typical example of the most important point is in Köseke High Speed Tunnel, T26. The tunnel collapsed. So they abandoned the tunnel. And in the past, we had crossover TBMs in two important projects. One is Gerede project and the other Cargo project. Crossover TBM did excellent job in Gerede project. It passed 48 fault zones and with high water ingress. And we had water pressure up 26 bars. It is very important. And so the geology is difficult in Turkey. If you look at the map, you will see a lot of colors all over the places. It means that you have different formations of different ages, different faults, and different so on. So a good machine, well-designed machine, may cope with these difficulties. Otherwise, we have a lot of problems. We lose the tunnels and we lose everything. And the tunnels gets expensive. And the second part of your question is that, do you think other areas of the world have a similarity variable geology? I had experience in India, in Himalaya, and I worked in Parvati 2 project. I think these crossover tunnels, the TBMs, are excellent for this type of geology. In Himalaya, we have shear zones, rock bursts, and water ingress. And now high water ingress. Now I know that in India, there are a lot of projects just stopped because of these difficulties. And in the other part of the world, there are similar difficult conditions, but India, I think, is the most important country that these machines may be applied.
I think let's maybe take a step back to the Esme project. The reason we're here talking about this project is because of the world record advance rates. As I understand, it's the fastest machine ever recorded, over 13 meters in diameter. Şevket, could you talk a little bit about the performance of the machine on the project and how you were able to achieve those incredible world record rates?
Yeah. First of all, if we examine the performance of the TBM used on this project, 38% of the total time was spent on excavation, 27% on ring assembly, 21% on planed weighting, and 14% on unplaned weighting. An average of 60 minutes was spent for an excavation. Also, approximately 42 minutes was spent for assembly a ring. Planning weighting contains cut rate maintenance, day-offs, and OG cable and belt extension. Unplanned weighting contains faults of machine parts and the setbacks that we didn't predict beforehand. Among the total weighting, the most time was spent on cut rate maintenance with 28%. Shift brakes follow it with 22%. Rate of mechanical and hydraulic failures is only 8% among all weighting. Also, the rate of downtimes due to electrical failures is only 4%. The delays caused by mechanical, hydraulic, and electrical faults remain at very low rate. The main reasons for this are planned and regular maintenance, cleaning, a qualified team, and the team spirit created. The excavation of the tunnel completed in just 6.5 months. We reach a bus day width 32.4 meter, a bus week width 178.2 meter, and a bus mount width 721.8 meter of excavation raise in this process. We also set the world record among TBMs with 30 meter and larger diameters with 518.4 meters in July 2021 and improved on record the following 2 months. We could reach targeted advancement rates with scheduled maintenance periods, an expert team, and enough supply of spare parts.
That's an amazing result. Dr. Bilken, in your opinion, what are the most important factors that allow a machine such as this one to achieve fast advance rates?
There are 5 points which are very important. The first one, understanding the geology, the geotechnical parameters of the ground, and proper selection of the TBM. These are most important factors in the success of the project. The crossover TBM used in Esme broke 3 times world record. It means that the machine was selected properly. The second point is important, technical support of TBM manufacturer. It's very important because a TBM having such big diameter is electromechanically complicated. And you need the support of TBM manufacturers. And in this project, the TBM manufacturer supported the tunnel crew, the project manager, TBM technicians, everything. And it was the second point which was important. The third is the experience of the contractor and the crew. The experience of the contractor is important. The contractor was very experienced in mechanized excavation. I mean, the contractor was also the contractor in Gerede Tunnel. So the contractor had a lot of experiences in difficult conditions as well. And the contractor selected very experienced crew. The TBM manager is experienced nationally and internationally, and the crew as well. So not only the experience of the crew, but the experience of the contractor is important as well, because he knows the problems and he is ready to pay you, because if he doesn't pay for difficult conditions to solve the problems, you can't do anything. Third and the fourth, having experienced consultant. They had a very highly experienced consultant, previously a TBM group manager of a big metro project, was appointed as a consultant to the project. This was the fourth point. And the fifth point, which was the main points of the success of the project, the last but the most important is the project management and logistics. It's important. Job organization, job site organization, the production of high quality segments are important, and the cost of segments in any project, in mechanized project, sometimes is the half of the cost of all the equipment in the project. So the management and logistics was excellent, and experienced project manager was also at the top of all this stuff. So I can summarize: first, understanding the geology and selection of a good machine, and getting support from manufacturer is important. Experience of contractor and the crew. And I think in every project, excavation project, mechanical excavation project, the project has to have an experienced consultant. It is important. And the other thing is good management and logistics. You can't do anything without good management and logistics. That's all I am saying about that.
Those are all really good points. Brad, in terms of the design of the machine, what do you think are some key aspects of the machine design that led to its good advance rates or contributed to its good advance rates? And do you think that any of those designs could be applied for future projects?
Sure. Well, I think Professor Bilken, matching the machine to the geology, and especially if that becomes, of course, more of a challenge as the geology becomes more complex. Maybe a little bit more simplistically, of course, there's elements like, cutter head layout and design elements, let's say, but more broadly, it really comes down to, can you remove the muck efficiently, address the ground and the geology at the face with the cutter head and get it moved out. But then the logistics of the machine, if it can mine efficiently, that's great. But if it's held up by the logistics and the backup in the tunnel, so being able to efficiently work, it's a moving factory. So being able to efficiently move in there, and especially when we talk about segment erection, that was touched on briefly. Here we were able to spend this percentage of the time on segment erection, this percentage of time on mining. Really, how quickly and efficiently you're able to bring in those segments, erect the segments, become, those are core aspects of really any machine. But certainly for this machine and the design of a crossover machine, that stands true here. Looking to other projects, I think the crossover elements become add to its flexibility and the ability to apply this machine to a wider variety of projects and really effectively apply it to a wider variety of projects. So you can still use those core aspects, the logistics, the segment erection, really on any segmentally aligned tunnel. But then as you apply it to more of a rock project, let's say, or a harder rock project or more of an EPV project, you're still going to see those high performance rates. So it's the flexibility and the number of projects that you're able to really effectively apply the machine gets opened up.
Great. And Dr. Bilken, can you talk a little bit about what the success of this project means for Turkey and for the tunneling market?
Well, last December 21st and 22nd, we had an international symposium in Turkey, tunneling symposium. And Brad attended this symposium. And a lot of government people and from municipality and the government attended the conference. And they talk about the future projects and the current projects. We have 100 kilometers of inland metro tunnels, roadway tunnels, utility tunnels, highway tunnels. And all these projects were discussed in the conference. But you will ask me, do you have money? The money is important. It is a fact that at the moment, Turkey has some economical problems. However, Turkey is a big country, and I believe that it has the capacity of overcoming economical problems. As I repeated in different conferences, in different international conferences, seminars, opening tunnels in Turkey is like a bullet coming from a gun. You can't stop it. We will have a lot of projects in the future. And your second question is what the success of this project means for the country. I think it means a lot. Another fact that we gained from Esme Tunnel is the number of TBM crew inside the tunnel was 36 or 37. Is the same number as a EPB TBM working in a metro project having 6.6 diameter. So the diameter of TBM is doubled, but the crew is the same. The number of the working people is the same, is important. The other important point is my favorite thing. I calculated specific energy for Esme tunnel and for other tunnels in metro projects having almost the same geology. The specific energy, which means the energy to spend a unit volume to excavate a unit volume of rock, is less with big diameter TBMs. So it is economical. So in Turkey, we have a lot of metro projects. And for this new airport project, Istanbul Airport project, we had two lines. Each line has 76 kilometers. No, each line has 36 kilometers, but it is double twin tunnels. They are twin tunnels. So instead of excavating a tunnel having a bigger diameter, you excavate two tunnels. So it's more expensive. In one of the metro projects, which I was consultant, I suggested to use to the government a bigger diameter TBMs, but they refused. Do you know why? Because at the moment in Turkey, the contractors has a lot of TBMs going on in different projects. They want to use these TBMs again. But the life of these TBMs are over now. They finished because some of them are 20 years old, some of them 15 years old, excavating many tunnels. And what I suggest, and I am preparing a presentation for the next symposium, how bigger diameter TBMs, crossover or bigger diameter TBMs, are more economical than driving twin tunnels. Why we are driving twin tunnels? It's expensive. So it was this project, Esme project, it was a good example. Now I have some numbers in my hand, in my presentation, and in my paper. I will put everything down to show how large diameter TBM is more economical than using two smaller diameter tunnels like in Istanbul metro tunnels. So it was important. I thanked to this gentleman who did a lot of tremendous good jobs, and it is good for country as well.
Brad, in terms of the future for large diameter crossover machines, where do you see the designs heading in the next 5 years? Do you think there will be more large diameter crossover projects, as Professor Bilken is saying?
I think it's fair to say that we certainly hope so. I think the product line as a whole is pretty well developed. I mean, it's a pretty broad offering. but there is certainly refinement to be made. So it's more of the overall concept is there. Then it's looking to the future. We're refining certain aspects of it, either simplifying it if you have to change over, mechanizing certain aspects of it, especially that there's more opportunities in the large diameter for that sort of work. So it's at this stage, they're a well-developed product, and really it's getting them applied to the geology and let's say customizing it to that particular suite of geology.
Okay, great. One last question for all of you. If you could each summarize today's webinar into one key takeaway for our viewers, what would it be? Maybe start with Brad.
Well, for all the successful projects, I mean, we've touched on, there's so many elements that need to line up to really make that project successful. And I think it ultimately starts with people that are making the project, the contractor. They have to maintain the machine. It might be a great machine, but if it's not maintained, it doesn't, do anybody any good. The logistics might be pretty well worked out, but they have to be executed. So it's marrying up that the ability to, experienced crews being able to operate, maintain the machine effectively, matching the machine to the geology. So understanding the geology and being able to everybody work together basically to move that project forward and make it successful. So it's getting all those elements lined up and working together.
Great. Shevket, what do you think?
We are proud about we have disproved the idea that it is not possible to reach high advancement rate while using EPB type machines with large diameters. For machines with large diameters, professional staff, TBM choice, soil analysis, logistic network, the stock of spare parts and motivation are all cogs in the wheel. And with the coordination of this, it is inevitable to reach planned excavation rates. Also, I think there was a very successful and productive presentation here today. Thanks again for your innovation. I wish everyone success. Thank you.
Thank you. Professor Bilken, what would you like to say?
It was a good example for Turkey and for all over the world that a large diameter TBM may reach so high advanced rates. But you have to understand geology, as I will always repeat, good organization, good management, and you have to have a support of the manufacturer, because all these machines, big diameter machines, are like big factories. You have plenty of electromechanical devices all over the places, the machines, pumps, hydraulics. So always it is necessary to have the support of TBM manufacturer. You have to listen to them. It's important.
Great. I think this has been a great discussion today. Thank you everyone so much for your time. I'd now like to start our live Q&A session. So please enter in your questions in Zoom and we'll get started.
We've got about 10 minutes or so to do our Q&A today. We have all of us here to answer your questions. It looks like we have quite a few technical questions today. Let's start with a question for Shevket. Did your team do probe drilling during the tunnel bore or any pre-excavation grouting to reduce groundwater inflow?
We didn't need to use probe drills during tunneling because I mentioned before we did a sufficient amount of ground drilling before starting the excavation. To remind you, we did drilling every 200 meters along the line. It was observed that the soil encountered during the tunnel excavation largely matched the data obtaining from the previous drilling. On the occasion, I must state again and again that while drilling at least 200 meters apart is very important in terms of tunneling, thus the need for drilling with a probe in the tunnel will be minimized, as is the case here. Thank you.
Okay, great. And here's a question for Brad. In general, for crossover machines, how long does it take to change from EPB to hard rock mode, and what types of procedures does this include?
Well, in general, it's going to depend really heavily on the specific machine design, the diameter of the machine. So in the case of this project, it was a lot easier just because you had the belt conveyor and the screw conveyor installed at the same time. So then it's a matter of converting the cutter head. And that conversion is going to, again, depend on how much you want to optimize it for the mode of excavation. So on crossovers in general, you know, if it's something like an XSE, it can be, you know, very, very quick, less than a shift, you know, to change those modes because it's minimal on the cutter head change, or it can be several weeks, again, depending on the diameter of the machine and the degree that you're modifying the machine.
Okay, great. And Dr. Bilken, you mentioned a number of important factors that contribute to fast advance rates and a successful project. What would you say is the most important factor?
First, you have high machine availability, a high machine utilization, high penetration rates. And for this, you have to have a reliable machine suitable to the ground, and experienced crew and contractor are the other important points. That's all.
Okay. Brad, how important is the design of cutting tools in achieving fast advance rates?
Fast advance rates, especially overall advance rates, as the geology becomes more difficult, I would say the role of cutting tools becomes more important. So that comes into longevity of the tools. So the design of the tools kind of leads to longevity, how often you have to stop. And of course, those stops are a significant, have a significant schedule impact. And then of course, you know, as you get harder geology, you know, how much you can load up the ground and how fast you can excavate it, matching that tool to that ground. So I would say it's very important, especially as you get into more and more difficult geology.
Okay, and for Shavket, did you experience any logistical or technical challenges with getting material and supplies to such a large machine?
Some challenges were encountered due to the large diameter of the TBM, especially during the transportation of the TBM due to the large tonnage and size of the parts. A number of studies were carried out before the transportation, from road arrangements to the manufacture of the new transportation road. However, all the challenges that may be encountered both in terms of logistics and technique were predicted with good planning and solved without any problems. Thank you.
Okay. Dr. Bilken, what should contractors know about tunneling through particularly unpredictable and variable geology, such as that found in the Himalayan mountains that you mentioned?
Well, for example, in Himalaya, you have a high overburden and shear zones with a high amount of water. So you need segment lining, and a robust, reliable machine to resist face pressures up to 15, 20 bars. And prop drilling is the other important point. Prop drilling is not drilling. You have to understand, you have to feel. So, experienced geologist who knows how interpret drilling rates from prop drilling is necessary. So there are a lot of papers published on the subject. I think everybody must go through them to understand the importance of prop drilling. Thank you.
Great, thanks. And Shevket, what ground conditions were anticipated in the geotechnical baseline report? And how is the TBM equipped to deal with those conditions?
As stated in the report, we expected initially heavily altered gneiss, followed by mudstone containing claystone and sandstone units. It was as we expected. Since we were excavating weak soil content, we increased the hardness of the disc rings by changing the dimensions to 1 inch instead of the standard 3/4 inch. Thus, we have greatly reduced disc wear. We have also strained the cutter scrapers by increasing their size and aiming to provide minimal wear on the cutter. Apart from this, we planned and achieved maximum efficiency by determining the form selection in different types according to factors such as clay density and abrasive soil. Thank you.
Okay. Dr. Bilken, how can planners, engineers design above ground facilities and segment production to support faster TBM advance rates?
Sorry, I'm not with you. Can you explain?
Sure. I think the question is, how can faster advance rates be supported with above ground structures, such as segment production plants on site, facilities, things like that?
Sorry, I can't explain that. Sorry.
Okay. There were also some questions, Dr. Bilken, about your comment on doing 1 large diameter tunnel versus 2 smaller twin tunnels, and if there's ever any exceptions to that due to tunnel depth.
Well, in twin tunnels, the one advances in front and the other comes behind. So the ground is just disturbed. And this is the problem. For example, in one of metro project now, the first TBM finished the tunnel, but the second one has the problems. So why we are driving twin tunnels? For me, it's just inexplicable. I can't explain that. It's better to excavate a larger tunnel than driving twin tunnels, because you have problems with twin tunnels, especially in complicated geology. The second TBM coming from the behind is affected from the stress of the first going in front. So it's a problem. Okay.
Okay, that's interesting. I think we have time for one more question. Brad, do you think there is a maximum diameter for crossover TBMs? And also, is there a minimum diameter?
For a maximum, that's going to match up with the TBMs themselves. Wouldn't be specific to a crossover type machine. And in many ways, it gets easier to design in crossover features as the machine gets larger. On the other side, it really becomes a trade-off of the difficulty of changing over the machine. So in like an XSE or crossover between slurry and EPB, that's can be a little bit easier exchange. So you can probably go a little bit smaller. We've run down to 3 meters for a rock EPB type conversion. So you can go quite small, but it really becomes a trade-off of the efficiency and how easy it is to change over from one mode of excavation to the other. But in general, you can go, it has a very wide range of application.
Okay, great. So that's all the time we have for Q&A today. If we didn't get to your question, we'll send you a follow-up email with a response in a few days. After you exit the event today, you'll receive a survey link. Please take a few minutes to take that survey. We do use your responses to improve our future events. Thanks and have a great day.
Thank you.